Hey y'all, thanks for joining me today. My name is Matthew Storch. I'm with Charlotte Mecklenburg Stormwater Services. Today I'll be presenting on low-cost flood sensors in Urban Installation Guidebook. My co-presenters Josh McSwain and Ryan Spidell will be joining us afterwards for the live Q&A. So, quick agenda. We'll do an overview of the low-cost flood sensor project. We'll spend the bulk majority of our time on the Urban Installation Guidebook itself, talk about the final product, and then have time for the live Q&A. So Project Catalyst. In 2018, Charlotte Mecklenburg Stormwater Services partnered with the Department of Homeland Security, Science and Technology Directorate to test low-cost flood sensors as part of a 3-year grant. Now, why Charlotte Mecklenburg? Well, for starters, Mecklenburg County has an estimated 370 miles of FEMA map streams and approximately 2,800 houses and buildings in map floodplain areas. Needless to say, we are prone to flooding. Additionally, Mecklenburg County already had a mature flood warning system known as FINS, which stands for Flood Information Notification System, which you can see on the right. We had the organizational capacity to deploy, test, and maintain low-cost sensors, a detailed inventory of flood-prone structures, and proven application of flood risk scoring tool, as well as the vision for the project. Like I mentioned, this was a 3-year project. In the base year, we focused on 2 things: the deployment of flood sensors from 3 different vendors, which you can see on the far right, and then risk tools. As part of our flood sensor deployment, we evaluated and reported on the deployment of the flood sensors and prepared a field deployment plan for the low-cost sensors in option year 1. The risk tools consisted of conducting national outreach for a community guidebook, performing risk tools needs assessment, and converting a legacy tool to an updated platform. So option year 1, we moved from 3 vendors down to 1 based off of our experience and what we thought had the most potential. We then went ahead and deployed 98 flood sensors utilizing risk-based criteria to fill in the gaps of the pre-existing FINS network. You can see the image on the right is a map showing in the green circles pre-existing USGS stream gauges. The red triangles are the alpha low-cost sensor units. And then the blue squares were the locations where we plan to deploy the beta low-cost sensors. Additionally, we learned a lot of lessons from the base year and applied them to the option year 1 to improve our deployment techniques. Option year 2, which just wrapped up in April, consisted of the integration of the flood sensor data and the risk tools. I would highly recommend that y'all tune in to Talk D5, Case Studies and Risk Communication with James Scanlon to learn more about option year 2 and what you can do with the data. Like I said, we're going to spend the bulk majority of our time on the Urban Installation Guidebook itself. So during option year 1, we were asked to develop an Urban Installation Guidebook. And the question we had to ask ourselves was, what was the goal? Our answer, it was to help other communities and stakeholders such as yourselves with the lessons we learned so that you could have a successful low-cost sensor program. On the right is the cover page of that Urban Installation Guidebook, and below is the hyperlink where you can view the document in its entirety. In developing your low-cost flood sensor network, first step is site selection. Site selection is a critical first step in developing an LCS network. Direct knowledge of the local conditions is invaluable. However, without a systematic analysis of the available data, concentrations of flood risk could be overlooked. Additionally, development of a risk-based site selection protocol will allow a community to prioritize resources, communicate with stakeholders and elected officials, and develop a response plan based upon data generated by the LCS network. So step 2, deployment planning. I highly emphasize that y'all spend a considerable amount of time on your deployment planning. Considerations to make. In Mecklenburg County, we developed a right-of-way agreement with the City of Charlotte Department of Transportation. Communication reception. So in Mecklenburg County, we do have good cell reception, but we do have some limitations due to canopy cover. So due to the canopy cover, mesh networks, which is a bunch of radio units that communicate to one central cell modem, wasn't really viable for us. But if you're somewhere without a lot of canopy cover, that may be a great solution for you. You may be out west or somewhere with bad cell reception and may be in need of iridium or satellite. So just know what your needs are and then base your procurement of flood sensors off of those needs. Sensor capabilities, alerts, and notifications. So generally speaking, flood sensors are going to be monitoring for water level stage. A lot of units will also measure things like barometric pressure, air temperature, water temperature. Some will have rain gauges. Again, I'm going to say this kind of time and time again, but figure out what you need and then find a vendor that meets those needs. Depending on the vendor that you go with and the platform that you use to present this data, you may have different capabilities for alerts and notifications. On the right are 2 images from our FINS platform. The top one is a stream gauge at rapid deploy FMB 071. The bottom line is the stream gauge height. The blue line is full bank, and then the black line, I believe it's black at the top, is road surface. So Mecklenburg County, at all of our deployment sites, we conducted GPS work to determine the location of the head unit, the lower sensor, full bank, and then anything that we wanted to monitor, whether it was a road crossing, critical infrastructure, apartments. And then we imported all that data into our FINS program so that we could set up these alert levels. So let's say that the stage reaches full bank. We've set it up so that an automatic email will get sent out to internal staff and emergency management, maybe the local community, letting them know, hey, water levels at full bank, just a warning, or let's say it gets up to the road surface, even more so tell emergency management that they need to go close that road down. Data transmission and storage. So on the right is an image from one of the vendors of their data viewing platform. That's one way to get your data. And then faded just in was the FINS platform, which we use data transmission. You got a lot of options. It can go straight to the vendor. It can go to your own server, or it can be a repetitive system where it goes to the vendor and then is fed to your servers. So again, know what resources you have available. If you have a pre-existing platform like FINS, like we do, that's something that you want to communicate with your vendor. If you need a platform and you have certain expectations for its alerts and notification capabilities, communicate that with the vendor. Accessibility for installation and maintenance. So now we're getting more into the physical install for your deployment planning. So when you're selecting the sites that you want to monitor, it's crucial that you make a visit before you go out there to deploy the unit. And the reason why is, if you got really steep banks or a lot of accumulated debris, it may not be accessible for an installation or maintenance. Do your homework, take pictures, make notes. Along that point of site visits, sunlight availability in Mecklenburg County, as I mentioned, we have really heavy tree canopy. So getting optimal solar availability and the southern orientation was very important for us. And some sites that we wanted to monitor, we couldn't because there just wasn't enough sunlight availability. So take that into consideration when you're selecting your sites and making your site visits. Along that point, vegetation, the photo on the right, you can see halfway up the pole is one of the flood sensors from auction year 1. It is covered in kudzu. This happened very rapidly in the springtime. Having a good operation and maintenance plan is a good way to avoid this, but sometimes you just gotta know what your surroundings are and take this into consideration. In-stream sensor, wet sensor placement. So if we are looking to monitor for creek stage, a lot of us are going to want our sensors in the creek. That being said, you have to consider that there's going to be really fast water moving, debris, other objects that could affect your lower sensor. So just take that into consideration. Things to avoid: really steep bank channels, channels with high sinuosity, point bars where debris can accumulate, and then you want to avoid like stream blockage sites maybe, because that has a high potential of damaging your in-stream sensor. You can see in that image is the conduit that we use, which is 3/4 inch non-metallic flexible conduit. You don't want that running across the entirety of the creek. If you want to monitor the left bank, have the sensor enter from the left bank. Don't run it from the right bank all the way to the left. You're just asking for trouble. The alternative to in-stream wet sensor placement is dry sensor placement. You can see that in the photo on the right. Much lower consequence because you're not running conduit anywhere from 10 to over 100 feet to make it to the creek. It can be very close to the head unit. Vandalism is going to happen. You can see the antennas were broken off on these units. Our findings have been generally, we haven't had a lot of vandalism. What we have had is pretty minor. And then also putting signage on it so that the community knows why the technology is there also helps deter vandalism. Surrounding utilities. Before you start your installs, get everything marked. You don't want to be driving a pole into the ground and hit a gas line. So make sure you're calling your local utility finding company and get that done. Again, doing your homework, know the distance from your head unit to the in-stream unit. You're going to have to procure materials, and you want to know how much you need when you're going to do your installs, not once you're out there. Use satellite imagery and figure out what sort of materials you need. Then lastly, anticipated flood depth. In Mecklenburg County, we generally speaking deployed all of our head units outside of the 100-year floodplain. You don't want to have a huge flood event and your head unit is underwater and it's broken and not sending you data. So just know where you're putting your equipment. Step 3, materials needed. Keeping with the concept of low cost, we've listed out every piece of equipment that we use for our installs here. It's also in the image on the right. And as you can see, it's all pretty standard equipment. It's not super expensive or specialized. We wanted to make this accessible for pretty much any community, stakeholder, private individual looking to buy flood sensors. And this list can be found in the Urban Installation Guidebook. Step 4, doing the actual physical install. We've broken it down to 4 steps: attachment and positioning of the head unit, routing and protection of the cabling, attachment and positioning of the in-stream sensor, and then final install steps. So the head unit installation, in this first photo, we can see the installation of an 8-foot galvanized fence post using a T-post driver. Then secure your mounting bracket to your post or pole, and then secure the head unit to the bracket. We were using metal zip ties of a sort here. There's a myriad of devices and it's probably going to be vendor specific. And then the photo on the right, you can see 4 different ways that we've installed head units. Use infrastructure if it's there. There's no need to put another pole in the ground if you got something there already. Routing and protecting of the cable. So in the flood sensors that we have seen, there is always a physical data communication cable that connects the in-stream sensor to the head unit. If you've just got that on the ground, there's a high potential of it being damaged. We started using 3/4 inch flexible non-metallic PVC conduit, and we would run our data communication cable through it. It's been a great way to protect the cable itself, but you also need to secure the conduit. If you've got a 30-foot run of conduit and there's a flash flood coming through, I can assure you that that lower sensor is not going to be there after the storm. So we've used everything from riprap, landscape staples, and most recently have adopted the use of these rebar J hooks, which have been great for securing our conduit. They can be found on Amazon or at a lot of hardware stores. Attachment and positioning of the in-stream sensor. So in our base here, we were using T-posts to mount our in-stream sensors on and found a lot of debris was accumulating on them. We've since adopted using a 3/4 inch, 24 inch long round steel stake. Step 2 is attachment of the in-stream sensor to a mounting bracket. We just had some angle bracket cut and drilled to spec to mount these particular lower sensors on using a mixture of stainless steel hex heads, nylon lock nuts, and stainless steel hose clamps to secure the conduit and lower sensor. And then attach the mounting bracket to the steel stake itself using stainless steel U-bolt and then those stainless steel nylon locking nuts again. So, final installation steps. After the 3 main components of the LCS are installed, the head unit, cable, and in-stream sensor, take any last installation measures, clean up your sites, any loose cables, tidy them up, attach signage. Like I mentioned, that's a great thing with vandalism, but also it's education for your community. And I touched on this earlier, site surveying to figure out what technologies and resources are available to you so that you can survey your equipment and make your data really work for you. And then probably the first thing you should do, it shouldn't be a final installation step, is refer to your vendor specific installation guidelines, because their instructions are going to be very specific and unique to the equipment that they've built. So it should be the first and last thing you do. Always check with the vendor specific guidelines. So installation process takeaways. Number 1, be flexible in your deployment. You may want to monitor in a certain spot, but if you can't get there to install and maintain the unit, it's not going to do you much good. Use pre-existing infrastructure to mount your head units. Just be overall flexible. There's a lot of things to consider. Secure your site. If you want these low-cost flood sensors to work for you for a long time, you need to maintain them, secure your site, vegetation control, things of that nature. And the last one is monitor your data. Get your data to work for you, your community. Set up those alarms and alerts. Figure out a platform that works for you, but use that data. Don't just let it sit there. And then step 5 is maintenance. So during option year 1, Mecklenburg County personnel conducted monthly site inspections. We cleared debris, did vegetation control, checked for physical damage, and then took a validation measurement. Since July of 2020, we've done the same process, but just on a quarterly basis. And on an as-needed basis, we address issues such as vandalism, failed components, and/or storm damage. And then in line with that, develop yourself a site assignment and prioritization listing. Prioritizing your sites is really helpful. If you have limited resources, you know what sites provide the most valuable data, and which sites then should get the most attention. Just a useful tool to have before you need it. I'll put it that way. And then track all maintenance and operation activities. Mecklenburg County uses an in-house database called Environmental Data Management System. We track any field work done, validation measurements, really helpful tool to have for your annual reports, for communicating with stakeholders in the community at large about what's being done with these flood sensors. And then a question we always get is, what about costs? These are supposed to be low-cost flood sensors. Well, the cost of your flood sensor is going to be vendor dependent, so I'm not going to speak on that. But what I can talk to you guys about is in Table 1, material costs. So generally speaking, we were finding that sites were costing us $75 per site. And then Table 2, what about labor? So we're finding installs, if it was just one person, it would take approximately 2.5 hours per site. During the peak of our installs, with about 4 of us, we had it down to about 30 minutes a site. And then monthly checks and validations, give or take 30 minutes at the site, but then you need to factor in driving time. So just something to consider. In repairs, it's all dependent. So final product, you spent all this time with your site selection, your deployment planning, the actual install. What do you have for all of your labor? Well, you have a physical network of flood sensors. You have a data presentation platform. You have the tools for communication and outreach. And you also have the tools needed to further enhance your flood mitigation program. What we found is we're able to reduce fatalities from flooding events, reduce property losses from future events, support community flood resiliency, and provide flood predictive analytical tools. So again, there's a lot of potential for these programs. It's just what sort of investment do you want to put in and what are your hopes for it? Again, my name is Matthew Storish. I'm with Charlotte Mecklenburg Stormwater Services. I want to thank you all for joining me today as we talked about the Urban Installation Guidebook. There's some hyperlinks below to Charlotte Mecklenburg Stormwater Services low-cost flood sensor page, also our FINS page, and then the Department of Homeland Security, Science and Technology Directorate low-cost flood sensor page. Myself, Josh McSwain, and Ryan Spidell will be joining y'all for a live Q&A now. Thank you very much.